Okay. So we are working on angles formed by secants and angles formed by tangents today. So if you would open up the file, I think it's CI2 notes part 2. All right, we're going to start here where it says theorem 1. Okay, first of all, what is a tangent? Ella, thank you. Good. It is a line that's going to be perpendicular to a radius. It hits that circle in one spot along its circumference. What is a secant? Ella?
Does it cut through a bit of the circle?
Uh-huh. Yeah. So a secant line is just any line that just hits the circle and intersects in 2 points. So this is a secant. And then the tangent line is going to be something more like this, where it just touches tangent. So tangent doesn't intersect the circle except for that one tiny point. As a secant intersects the circle in 2 places. Okay, so theorem 1 says if a secant and a tangent intersect at the point of tangency. So here we have our tangent. The point of tangency is that little spot where it hits the circle. So it actually continues on the other way, but that's not important. And then the other line, this line here would be the secant. They just didn't draw it extending. Okay, but it's still a line that hits the circle in 2 places. So we've got our tangent and our secant. And if they intersect at that point of tangency, then the measure of the angle formed is half the measure of its intercepted arc. So what they're saying is this angle here that they have marked as 89 degrees is half the measure of the arc it makes. So let me see if we can simplify this so it doesn't have a whole bunch of other writing on it. So we draw another circle. And we draw a tangent line. And a secant line. Now, these are not perpendicular because this secant is not a radius. So you've got something like that. So the angle formed by those two, come on, is half of the arc. angle is half of the arc. So it's the same thing on the other side. I could do the larger part of the angle. I could do this side of the angle, the obtuse part, and that would be half of the major arc. So it doesn't have to be just the small side of the large, or just the small side. Both sides work. All right, angle is half the arc. Just like when they're inscribed. Right, Eli? Morning. Okay, so let's do the numbers that they gave us. If the angle is 89 degrees, we need to find x. So which one do we double? Do we double the 89 or do we double the arc? The angle is half of the arc. Amber. Absolutely. Double the angle instead of equal to the arc. So we know this arc is going to be whatever 89 times 2 is, which is 178. So our arc is going to be 178 degrees. I distributed the 1/2. So x equals 16. Ella.
I'm confused. Wouldn't you put 89 equal to a half times 22x plus 4?
No, the arc and the angle are not the same. The arc is double the angle, or the angle is half the size of the arc. So it works a lot like it did when we had inscribed angles. So imagine if our tangent and our secant were actually the diameter and the tangent. Whatever. I'll scroll back down.
I thought the same thing at first because it had the 1/2 on it. Yeah.
Oh, yeah.
It's like 1/2 is part of the arc.
Yeah, it was just part of their expression. Yeah. So if our secant line was the diameter, then this would be a 90 because that we know that tangents and radiuses are perpendicular to each other. So if that was a 90, then this arc is going to be 180 because it's half of the circle. So you can always kind of go back to this thing that you know and check yourself. Okay, my angle is half the size of the arc, or my arc is twice as big as my angle. Yeah, that half down there really does kind of make things a little confusing. Okay, so this works just like the inscribed angle did, where the angle was half of the arc. Okay. Theorem 2 says if two secants are in the interior of a circle, then the measure of the angle formed is half the sum of the measures of the arcs. Okay, so I'm going to draw one without a bunch of information in it first. Nope, I want a circle. So you have a circle with two secant lines. Now, they're not drawing them extending out, but they do. They just keep going. But they don't, you don't need any information past the circle, so they don't extend them. What do you know about the angles inside there? They're vertical, which means they are the same. Okay, so those two angles are congruent just because it's two lines that are crisscrossing, and they are vertical angles. Okay, so they're going to be the same no matter what. So that's going to be an X also. So then we have these two arcs that are formed. An arc over here, and we have an arc over here. And I'm using the ones that are opposite the angles I marked. There's a top arc and a bottom arc, but I didn't mark the top angle and the bottom angle, so those are not the ones I'm looking at. All right, I'm using the angles that are with, I'm using the arcs that are with those angles. So one of those angles, let's say this was 60 degrees, is equal to the two arcs added together times a half. So the arcs are still twice as big as the angles, but we have to use both arcs. So this one might be 30 degrees. And then this one might be, I need to add up to 120, 90 degrees. So the two arcs together are 120 degrees, which is twice as big as that 60-degree angle. All right. But I want to show you another example. Let me add a page. So you can see what's happening here. Circle. You got your circle. And let's go back to that one, inscribed angles. Okay. If our angle was 30 degrees, what was our arc? 60. Okay. I'm just going to extend these lines a little bit. So I haven't changed anything, right? Just made those lines longer. So now I'm just going to move the circle. My angle is still 30 degrees. But notice how this arc is now a little bit smaller than it was because of the way the circle slided. So when that arc shrank, this arc over here on the right-hand side grew. So those two arcs are still going to add up to 60 degrees. If I slide that circle even more, slide it to the middle, where now that intersection's in the center, now those are both 30-degree arcs. Because now it's a central angle. So now they're both 30. Those add up to 60, just like it did when it was kind of off center. We slide it even more. Now we've got the small arc on the left and the big arc on the right that's going to add up to 60. And if you went all the way over that way, and my lines were long enough, you'd have the 160-degree arc on the right. So no matter how that circle is positioned along those two intersecting lines, the arcs add up to 60 degrees. Okay, does that kind of help solidify it just a little bit? Amber.
So the outside arcs added together are double the inside?
They're double the angle. They're double one of the angles because you got a 30 on both sides. Yeah, so like when that was right in the center there, you got the 30-degree arc and the 30-degree arc. So you got the two 60-degree arcs if you're doing left and right. Okay. So let's take a look at the example they gave. Find the value of x. If the large arc is 85 and the small arc is 35, arcs are twice as big. So the two arcs together should equal 2 x's. The arc is twice as big as the angle. $85 plus 35, 8 plus 3, 8, 9, 10, 11. So that's 120. So 60 is going to equal x. Ah, look, I used 60 in the example and I didn't even know it. So that circle can slide back and forth on that 60-degree angle. And those arcs, no matter where they are, will add up to 60 degrees in some fashion. Alrighty. Third theorem. When you have if two secants or a secant and a tangent or two tangents intersect on the exterior of a circle, then the measure of the angle formed is half of the positive difference of the measures of the intercepted arcs. Okay, so that sounds like a whole lot. Let me draw it down here. So you got a circle, and you've got some lines intersecting it. And it could be two secants like that, or it can be a secant and a tangent. But what's happening is you have two lines that are intersecting, and they're meeting at a point outside of the circle. The main idea there, point outside of the circle. So you have an angle. This is the angle of concern way out there. And then you have the two arcs. You have the small arc, and you have the larger arc. All right, now let me remind myself. Arc minus arc. Okay, so angles have always been half the size of the arcs. Still is in this case. If this angle is, I don't know, 40 degrees, then it is going to be twice as big as the arcs, but this time we subtract. We're going to take the large arc, I don't know, what's that, 100? Minus the small arc, degrees. And that's going to equal the angle. This is going to be large arc minus the small arc, and that's going to equal twice the angle. Sorry, guys. Large arc minus small arc equals twice the angle. So before it was the two arcs added together equaled twice the angle. When the angle's on the outside, it's the two arcs subtracted from each other equals twice the angle. Still with me, Carson? Okay, you okay with that? Sort of, maybe. So we have our example here. We have a large arc that's 4x plus 5. We have a small arc that's 50. And we have an angle that's x plus 25. Large arc minus small arc is twice as big as the angle. And if you do small arc minus large arc, your answer is just going to be negative of what it should be. But hopefully you'll get in the pattern of doing the larger number minus the smaller number. So here we have 4x minus 45 equals 2x plus 50. Subtract 2x from both sides. Add 45 to both sides. Nope. 95. 4x plus 5 minus 50. Yeah, that's right. So x equals 47.5. So if we actually put these numbers in, I'm so glad they gave us a decimal here. 47.5 plus 25 is 72.5. And then 47.5 times 4 I'm filling in the numbers. 47, go away, 0.5 times 4 is 190. So this arc is 195. So if we do 195 minus 50, that's 145. That should be twice as big as 72.5. Amber. 95 divided by 2, unless I did that wrong.
Okay. I just looked at it.
Yeah, 2x equals 95. Okay. So the two arcs, if you subtracted them, then 195 and the 50, you end up with 145 degrees, and that's twice as big as the angle of 72.5. Arcs are twice as big as the angle every single time. All right, so let's look at, this is just a little review. This quadrilateral is inscribed in circle K. TR is tangent. Angle NLW is 78. Arc EN is 46. And LN is congruent to WE. Find each measure. Okay, measure of angle WEN. It is opposite of angle L. And one of the theorems we had a couple of days ago was if two angles are in a quadrilateral inside of a circle, then they're supplements of each other. So angle E must be 102. We didn't have enough arc information yet to figure that out without the quadrilateral rule. Okay, how about the measure of angle TEN? You need one of the new theorems from today to do this one. Specifically, theorem 1. So what's the measure of the angle? How big is the arc formed by angle TEN? It's 46 degrees. Arc is twice as big as the angle. So the angle is 23. Angle WER on the other side of there. Okay, we can figure that one out. We don't know anything about its arc, because its arc would be EW. I don't know anything about that. I don't have an angle that forms that arc. But I do have 3 little angles that are making up one straight line. I've got that 23-degree angle. I've got that 102-degree angle. And the last part must make it 180. So if you do 180 minus 102 minus 23, you get 55. So that angle's 55. If that angle is 55, how big is its arc EW? Other way. The angle is smaller than the arc. 110. Take the 55 times it by 2. Ella. TEM. Yep. Okay, I'm going to erase all that. Nope, wrong button. Okay, for TEN, what did we know? And out the view. Okay, so we knew that this angle was 102. And we knew the arc was 46. Okay, that's how I got it. So if we know the arc, so angle TEN, anytime you've got this tangent and then a line coming off of it, that arc that's formed is half the angle. And that's what theorem 1 says. Same way if we go the long way around. This arc would be half of this angle. We don't usually do those big obtuse angles, but it works. So if we know that that arc is 46, then this angle here is going to be 23 because it's half of 46. And if I go the other way, just to see that it works, the other supplement to 23, so this side would be what, 157? 180 minus 23. Right? So then how long is this big old arc going to be? That's formed by a 157-degree angle. 214? 314. 157 times 2. Well, 314 plus 46 is 360. So it works. Goes all the way around. Okay. So the nice thing here is there's still one main idea, is that the angle, one angle, is half the size of two arcs. One angle is half the size of the arc. Okay. You have an assignment in your Google Classroom. CI2 assignment part 2, you can do half of it. Okay, so here's page 1 is totally doable now. Page 2 is doable. There's nothing on page 4. Page 3, you're going to have to wait. Actually, even some of page 2. You can get down to number 10 with what we learned today. Okay? Angles are half of your arcs. Right? Any questions or concerns? All right. Anybody at home? Questions or concerns? All right, so it looks like we might be testing on Friday for this topic. So we're going to add one more thing tomorrow. That's Wednesday. We'll review Thursday. We'll quiz on Friday.